I'm just going to start sharing my screen and then about. So hello everyone. Please let me know if you can listen to me clearly.
I can hear you all right. There was background noise earlier, but we can hear your voice fine.
Okay. All right. So hi everyone. I'm Ashratuz Zavin Asha. I'm doing my master's in University of Calgary. My supervisor is Dr. Ehud Sharlin. So I'm working at the UTouch group interactions lab of University of Calgary, and I'm currently at the second year of my master's. And I completed my undergraduate in computer science and engineering major from Bangladesh. So this is all about me. In today's seminar, I would love to talk about my research background and then the research projects that I'm doing so that I can share my research outcomes and then the environment where I'm working currently. So I'm mostly working in the intersection of human-computer interaction and human-robot interaction. And my main research project is interaction between autonomous vehicle and pedestrians. So far as a second year of my master's, I have done other projects as well, but I'm going to discuss mainly my main project, which is with the autonomous vehicle. So before going further, I just want to give a short brief about the research area that I'm currently working on. One is human-computer interaction and then human-robot interaction. So human-computer interaction mainly depends on the design, implementation, and then prototyping and evaluation of the interactive computing systems. So we care about how to design interactive solutions that would be helpful for the people. So before designing a whole new system, we want to find out what is the people requirement and then how we can make the system more accessible and adaptable or acceptable to the community I'm working for. So that is the main core of human-computer interaction, is that it works on the human factors and try to design the system which is more on the user-centered. So in most of the cases in our research projects, we follow this process. So at first, when we are trying to find out a new research goal, we start with empathize process, which is we try to learn our users, what is their needs and what they require. So after that, we try to define what should be our research question and try to find out how we should proceed further so that we can gather the solution that we want. And we need to, whether we need to talk to the stakeholders or whether we can brainstorm ourselves with the interaction designers from our group, all those steps are done in the second step, which is defining the research question. And then we start with the ideation process. That means trying to find out the solutions that might help to create a new technology or new interactions. So I have done a lot of different projects, and I have followed mostly the same process of starting with empathize and then defining the research goal. And then I brainstorming with the participants or the stakeholders to find out the possible interaction or solutions. And then we prototype some proof of concepts to provide the idea that this is our prototypes. We might want to create something like this. So we build something which are very basic in a proof of concept prototype, and then we test it with the user by recruiting some other participants to see what is their feedback or insight on this, whether this is going to work or we should do more changes to before we can share our findings with the community. So this is mostly the HCA design process in overall. So going further, so HCA is a very interdisciplinary field. HCA process can be applied in many different sectors. So I have just pointed out some of the fields here. So it can be applied in computer science, it can be in sociology or psychology, it can be applied in software engineering or information security, this kind of very interdisciplinary fields. Then I want to talk about human-robot interaction, because my research area mostly in the human-robot interaction, but I'm following all the design approaches and methodologies from human-computer interaction. So I can say that it's in the intersection of both of these fields. So I'm currently working with the interaction, trying to find out the interaction between pedestrians and autonomous vehicle, and we are referring the autonomous vehicle as robots. That's why I'm studying in the human-robot interaction section as well. So human-robot interaction overall studies the interaction between humans and robotic systems, how we can build, design, and evaluate robotic systems that is going to interact with human, and we can provide a better interaction or improved interaction for that. And it also uses the knowledge and practice of human-computer interaction. It can also use artificial intelligence, data analysis, all of these fields. So now I want to talk about more details about my research project. So the main goal of my research project is to explore the interaction between autonomous vehicle and pedestrians, because in the current traffic, autonomous vehicle is going to come in near future, because many of the vehicles currently have some of the autonomy in those. So many of the manufacturers and commercializations is happening in autonomous vehicles. They are testing their vehicles, and we can assume that autonomous vehicle is going to be in the road in the near future. So when there is a new technology, we have never faced that, which is autonomous vehicle, how pedestrian is going to understand is this safe or not, because there will be no human driver there. So that is the main research area where I'm working. But my focus is that bringing the accessibility, because many of the research has already been done to find out the interaction between autonomous vehicle and all the ordinary pedestrians. But I'm currently working with, by considering the pedestrians who are using wheelchair, so that I can say that I'm working on a subset of this challenge, which is exploring interaction between autonomous vehicle and pedestrian in a wheelchair. So before going further, I just want to mention some details about autonomous vehicle. So there are 6 types of autonomy, but if we want to divide it in a broader way, we can say that 2 types of autonomous vehicle can be there. One is semi-autonomous and one is fully autonomous. We have seen some of these semi-autonomous vehicles already available. Tesla is having electronic vehicles with some of the autonomy there. Some level of automation, suppose steering wheel control or automatic brake, something like that. And what most of the practitioners and researchers is working for fully autonomous vehicle, when there will be no human intervention, but the vehicle is going to be able to take all the decisions about driving challenges or the weather challenges. Like it can find out when to change the lanes, and then it can understand when there are nearby vehicles, like it can identify the pedestrians, the signals, and everything by using its sensors, actuators, and then all the algorithms, artificial intelligence, all of this. So that's why we're considering autonomous vehicle as robots, because it can decide what it wants to do by itself. So many companies like Waymo, Tesla, and General Motors, they are already testing autonomous vehicle in the road, but no, as we said, that the main goal is no human intervention. That means there should not be any driver in the driving seat. But kindly, as they are testing in the current traffic in the actual road, that's why there is always a safety driver, because the technology is not that developed yet. It's near perfect, but not the fully perfect one, because we know that if an autonomous vehicle comes in the road, there might be many risks of accidents and also the acceptability of the pedestrians. So that's why they're having a safety driver on board in the vehicle, but the vehicle is driving by itself if something happens, so that the safety driver can take control and then do the stuff. So in my research project, the main research question is how we can design interfaces that can help a pedestrian who are using a wheelchair and assure them that it's now safe to cross the road or it is not safe in front of the autonomous vehicle. So how the pedestrian can understand what's the intention of the vehicle, like if the vehicle is going to stop for me or it is just going to drive, and if the vehicle has recognizes me that I want to cross the road now. So how this communication can be done by using different kind of interfaces, that is my main goal for the research. So I can say that I'm currently working in human-computer interaction. I'm using the human-computer methodologies to find out this research goal, which resides in the human in robot interaction field. So some of the backgrounds, because I said that many of the researchers have already been working on finding out interaction between autonomous vehicle and pedestrians. So this is one example where they have thought about having emojis on the vehicle, because as I said, there will be no human driver. So how to express if the vehicle has recognizes the pedestrian or what is next intention. So we can use the animated face there, or we can have LED strips which will be in the middle or in the side, or will have some animation on that. So based on that, the pedestrian can get some feeling that what the vehicle is going to do next. And then there can be also phone haptic. That means some notification will come to the user's phone saying that you can cross the road now, something like that. So they have ideated all these ideas. And then there is another work I have put it here. So this is all about using light bar in the bumper of the vehicle and having different kinds of animation to represent the intention of the vehicle, like is it in the rest, or it is going to start driving again. So all of it about this. So there are many research on this zone. So that's why we're trying to do a novel research, which is trying to find out the interaction between autonomous vehicle and people who are using a wheelchair, bringing out the accessibility, because no one has done this before by thinking about the accessibility or thinking about wheelchair users. So the research methodology we are following is, at first we start with the design study to find out different kinds of interface ideas, and then we analyze those data to find out what type of interfaces is going to serve the interaction best. And then we prototype some of the proof of concept interfaces. And then we evaluate those interfaces with more participants to understand if what we have designed is going to serve the purpose, or is going to serve the interaction or provide improved interaction for the users. So far in my project, we have done this design study portion. So we recruited 5 interaction designers from our UTouch group research, and then we conducted individual sessions with all of them, and we generated some low fidelity prototypes. And from each of the sections, we collected interface sketches and video recordings so that we can analyze this data later. So the procedure that we followed in our method was fictive method. We call this a participatory design technique that enables the participants to be a part of the design process by brainstorming with the researcher, by designing their ideas into papers or building some low fidelity prototypes. And then another tool that we have used is empathy tool, because we have recruited all the participants who are able-bodied participants, but we are working for the wheelchair users. So this tool helps to visualize the situation of a wheelchair users. So I'm going to describe how we implemented this idea. So this is the setup for the whole environment of the design study. We created a traditional physical crosswalk where we put in all these stationaries to help the designers to ideate their ideas. We put the wheelchair, which is an electric wheelchair, and we have this road area, then the street light symbols, all are just the different types of stationaries using and helping the, also we have a toy car here. So just to give an idea that there is a car coming and this is the crosswalk and you sit in the wheelchair. So we asked all the participants to sit in the wheelchair to empathize the idea of or feeling the situation of being in a wheelchair and trying to figure out what type of interactions we might want when there is an autonomous vehicle. So this was our design study environment. And then we asked the participants to use all these stationaries, some boxes, pencil and colors to design the interfaces in low fidelity interfaces by using these physical objects. So after getting the inputs from the design environment, like we have recorded all the design sessions, so we collected the video recordings and then we collected the designs that they have created. Like we have taken pictures of all those designs they have created in physical environment, and then we applied qualitative analysis on those, because those are all about, we transcribed all the video recordings, so those are all text, long and large pages of text, and then we applied the qualitative analysis on those. So we used open coding method. This is one of the qualitative analysis approaches. So we tried to find out the themes of those transcribed versions from the participants. So we identified the common threads, and then we divided those based on the codes. Suppose some of the designs were like, we want designs on the wheelchair. Some of the designs were like, we want the designs on the vehicle. So we separated those themes, and then we put some code to identify those specific themes. So I'm going to, okay, this is just a very small portion of what we did as open coding. I didn't share the transcribed version. Those are a lot of text. So after finding out the themes, we divided the category, and then we put the code, and then based on the location or how many times the participant wanted this, like how many participants suggested to use a button on the wheelchair or the display in front of the vehicle, something like that. So based on the design study, we found some of the interfaces. There are some screenshots where participants are sitting on the wheelchair and trying out different interfaces using the physical stationaries that we provided. Suppose, as you can see here, one is holding the button, just mimicking that we have a button in the wheelchair and we are pressing the button to tell the vehicle to stop for me so that I can cross the road. Also, someone suggested to have haptic feedback on the chair. Suppose when it's safe to cross the road, the chair will vibrate so that I can understand that, yes, now it's safe, the vehicle will stop for me and I can cross the road now. Initially, all those interactions, usually in current traffic, we do all these interactions with the actual driver there, like we nod our head, we wave our hands to just negotiate that if it's safe to cross the road or not. But in autonomous vehicle, we're thinking in fully autonomous vehicle, there will be no human driver. So how these interfaces can happen? So some of the ideas are like having push button and haptic feedback on the chair, because we are designing for the people who are using wheelchairs. This is another set of designs. Suppose having laser projection on the crosswalk, someone designed on a paper and just put the design on the crosswalk because it was all about low fidelity prototypes. And then someone added LED, like it was representing the LED, like the vehicle will say that I'm yielding now, you can cross the road now. So someone designed like this. So after getting those feedbacks and then finding out the what type of interfaces we might design by doing the data analysis using qualitative analysis and open coding, we have found some of the proof of concept prototypes that we want to design. So we have used the interface elements that was mostly highlighted by the participants, and then we prototype the interfaces in virtual reality environment using Unity 3D game engine. And then we used the Oculus Quest headset so that we can run those interfaces and engage into the virtual reality environment, and we can interact with the objects there. We also created one haptic device, which is a physical device will be attached to the chair that will generate the vibration. So before going further, I just want to explain a bit about virtual reality environment and also how we use the Oculus Quest. So in the Oculus Quest, we have used this new feature, which is hand tracking. There are cameras mounted on the Quest headset, and it can track the hands by using different algorithms. So whenever I put the hands in front of the Oculus Quest, it can track my movement. So we have used this hand tracking in our simulation as well, so that the user can push the button in the wheelchair, and it can provide the engagement with the objects in virtual reality environment. So we designed one haptic feedback by using vibrating disc motors, and there was Bluetooth connections. That means when simulation is going on in the Oculus Quest, it can send the information to the device so that the device can get those notification and vibrate on the chair. So we use Bluetooth connection, and then we use the vibrating disc motor so that the device can automatically connect with the Oculus Quest headset. And there are some examples of the interface prototypes that is created. So this is one interface where the vehicle is projecting the wheelchair symbol on the road, and then there is a street light which turns green. That means now it's safe, the pedestrian can cross now. There is another one which is on the vehicle. This one was on the infrastructure, that means on the crosswalk and on the street light. And this one was on the vehicle. It's not fully clear here. In the vehicle, it was saying cross, a text message. That means so that the pedestrian can understand now it's safe to cross the road now. And then there is another interface, which is if I push the button, then a wheelchair symbol will be projected from my wheelchair to the crosswalk. If it's red color, that means now it's not safe to cross the road. And then when it's safe, it will automatically turn green to make the user understand that now it's safe. There was some more ideas like if the user, suppose we created these versions earlier and then we generated another version which is more updated. So initially we use the wheelchair symbol here, then we have changed the wheelchair to pedestrian walk symbol. So if it's yellow, that means now I'm going to stop, you can start crossing, and then like adding some intermediate steps. Initially we were just turning from red to green, but then we modified our designs by turning from red to yellow and then green. That means adding some intermediate transitions so that it makes more realistic to the current traffic infrastructure. And then there is another interface that we designed that will be already attached with the wheelchair. If we have the push button and also a screen in the wheelchair, because we are talking about smart wheelchair or electric wheelchair, that will already have a power in that. So we can have different screen on that. Like some of the wheelchairs already have screens and they can have some operations on that. So we are just trying to use that concept, like there will be a screen on that and we are going to show the message on that screen. So if it's a stop hand, that means it's not safe to cross now. And if the stop hand changes to the walk symbol, that means now you can cross the road. Then here we tested another environment, which is another scenario, because so far we have seen a road and there was no street light, or the very basic street light just having the color. But now we are using here the regular street light that we see in the current traffic, like having the pedestrian symbols and also the countdown. So we added the countdown here. So these are some of the screenshots of the prototypes that we designed. So after designing those prototypes, now here comes the second last step of the design process, is that evaluating those prototypes. As I said earlier, that in the design study, we only recruited the able-bodied pedestrians and they generated the ideas based on their purpose. Though we asked everyone to think about the wheelchair users, think from the perspective of the wheelchair, but we all can understand that it will never be exactly the same because they didn't experience they don't have the life experience of being in a wheelchair. So that's why our next goal was to recruit a pedestrian who is using a wheelchair. So we wanted to recruit multiple participants, but as it was during the COVID-19 situation, we couldn't call them in our lab and conduct the study in the lab environment. So the study conduction was very interesting and also a very experimental one. Like we provided, we call these a co-design session. So I'm calling the participant as a co-designer. So we provided the Oculus Quest headset to the participant by delivering it from, like we delivered this Oculus Quest and also the haptic device. So, and then we conducted the sessions in 4 iterative sessions. There was 4 sessions. In the first session, we tried to understand the experience of this person being in a wheelchair and how he interacts with the autonomous vehicles. Then in the second session, we set up our environment, like we instructed how to install the APK files of our simulations in the Oculus Quest and how to install the haptic feedback. So we set up the whole environment in the second sessions. And then in the third session, we start evaluating our prototypes. So as I mentioned that this is a co-design session. So how the co-design session works, in the co-design session, the participant will share the feedback and insights from his lived experiences, because he is the expert in this case, because we know none of us, the researchers, didn't experience how it feels like being in a wheelchair and how what type of interaction we might have when there is an autonomous vehicle. So the participants provided all the feedback and insight based on our prototype and by considering his lived experiences. And then we are, as a researcher, we tried to find out those feedback and tried to map those with our research goal. So in co-design sessions, both the parties work together to find out the solutions that will serve the research goal best. So that's why, as we only recruited one person, that's why we conducted multiple sessions so that we can find out the feedback and we can modify our simulations. That's why, as when I was describing this, it was our first simulation that I showed to the co-designer. Then the co-designer mentioned that using the wheelchair symbols and then talking only about wheelchairs is making the stereotypes more noticeable. So he didn't like of using this wheelchair symbol. He mentioned about using the universal symbol, which is the work symbol. That's why in the second iteration of our study, we converted the wheelchair symbols to the universal symbols, because as a wheelchair user, he didn't want it to be singled out in front of the other pedestrians. So that's how we evaluated in the same time. At the same time, we modified our prototypes with the co-designer, and we used Microsoft Design Toolkit, which this toolkit provides the methodologies and approaches how we can understand a design from different perspectives. In our case, we are understanding the design from a wheelchair user. So based on our co-design sessions, we have gathered different insights and feedback from the participant. The participant mostly preferred the visual cues, that means the laser projection or the street light or the vehicle text, those type of visual cues. He also preferred the haptic feedback one, that means the vibration on the chair. And then most of the interfaces he preferred was on the wheelchair, because it gives them it empowers of using a wheelchair, because the wheelchair might have the power already, so we can attach anything with the wheelchair and it can talk to the vehicle directly. So if there is a screen in the wheelchair and the vehicle talks directly to the wheelchair, it's more empowering of use as a wheelchair user. So there was one scenario, I'm just going to back to the previous slide. As you can see, there is one scenario where we are not being able to see the vehicle. So we deliberately put this scenario where we put some obstructions. So being in a lower height while sitting in a wheelchair, there might be obstructions and the vehicle, he or she might not be able to see the vehicle movement. So it's hard to navigate in those situations. So we put one situation when the vehicle is visible and we can see that the vehicle is coming, but there is another scenario where the vehicle is obstructed by all these elements. So most of our findings, most of our interfaces were helpful for scenarios with visual obstruction. Suppose the scenarios that are on the street or on the wheelchair, it's more easy to understand. Even if I cannot see the vehicle, but I can see that my wheelchair, in my wheelchair screen, it's giving me hand symbol. That means, no, it's not safe, you should not cross. So most of these scenarios were appreciated by the co-designer. And then we have also seen that most of the interfaces can be helpful for other pedestrians as well. Like the haptic feedback, the vibration one could be helpful for the visually impaired pedestrian. If they cannot see anything, but there is a vibration, they can understand that yes, now it's safe to cross the road now, or if it's not safe. So we are talking about inclusive design so that we can design the solutions that would work for a large group of people. So as I said that due to some limitations, the research limitation, suppose we recruited only one participant and we delivered the Oculus Quest and the haptic feedback device to that participant only. But we cannot use the same Oculus Quest for another participant due to the in COVID-19 situation. Otherwise, our plan was to recruit a large amount of participants and conduct the whole study in our lab where we can use the same Oculus Quest. But now we needed to use an individual Oculus Quest for an individual participants that, and also it is very hard to find out participants who are using a wheelchair and who also wants to collaborate in such kind of research. Like it was a long time commitment. We conducted the research for 1.5 months. So it was really hard to find out the participant, but we are really grateful that we have found one. And also he is working in the universal accessibility and audit company in Canada. So it was really helpful to working with him, but our future work, our future plan is to do one more user evaluation with more participants who are using wheelchairs so that we can verify or we can find out the validity of the prototypes that we made, and we can put some generalizations on that. And as if you notice earlier that in the scenarios, we have just used only one vehicle and then there is only one pedestrian. So it was very basic because when we start finding out the interfaces, we always keep it simple so that we can find out the fundamental interfaces first. And then we can extend the scenarios by having multiple vehicles or two-lane road. Both vehicles are coming from both directions or multiple pedestrians. We can also consider different real world factors. Suppose I was using the laser projection, but if it's their lights of sun, maybe the laser projection will not be visible to the pedestrian, like those kind of weather or lighting, this kind of real world factors. So we didn't consider those in our preliminary proof of concept interfaces, but our plan is to consider those testing scenarios as well, and then evaluate this work further with more participants. So with our preliminary work of the design study, we published a late-breaking work paper in one of the premier conference in human factors, which is SKY 2020. I was supposed to present my paper in Hawaii, but I couldn't go there due to COVID-19. So I had to cancel my flights and everything. So I mentioned my main projects. So that was the end of my main project, but parallelly I did some other projects. One of these is designing external automotive displays, where we try to find out what if we use the side of a vehicle to display different information to the user, and how we can engage the user to have some interaction with the side of the vehicle. So we published a full paper in Automotive UI 20, and if you feel interested, you can check the paper, because I didn't add that because it was making the presentation longer. And currently, I'm working on another project where I'm trying to empower the usage of hearing aid. So we are trying to find out what type of cyber interaction there might be if a pedestrian who is using a hearing aid can interact with an autonomous vehicle, because the hearing aid also has the technology which can talk directly to the autonomous vehicle, or the autonomous vehicle can directly talk to the person's ear. So this is my current project. This is in very preliminary phase and it's still ongoing. So these are my research background and research projects so far, and these are the references that I have used in this presentation. Thank you everyone for listening my presentation, and please feel free to ask me any questions.
Thank you, Asha, for your presentation. I didn't know anything about vehicles or what they were doing in order to. I didn't even think about wheelchair users being a study group that you had to look at their interactions, and seeing the way that technology is evolving. I feel like this is very early, very early, but later down the road, people could be referring to this type of work. So thank you very much for your presentation. So I guess if anyone has any questions, to pop it into the chat. Oh, Asha, I have a question for you actually. So when you're doing user testing on something that is more physical, for example, you use the video tracking and then you transcribe that. How does that translate to doing user testing for a software? For example, if because right now, especially during COVID, you can't videotape how they're interacting with the software that's on their computer. So how is there a way that we could integrate that sort of user testing, especially to see like what features are being used the most and other things like that?
Yeah, that's a very interesting question. So there is a solution actually. So in the Oculus Quest, there is an option. That's why we actually implemented all our simulations in virtual reality so that it can be accessed remotely. So when the participant was testing our simulations, we instructed him to turn on the video recording option from the Oculus Quest. So we can directly record what he is seeing inside those virtual reality environment. So we were recording in the Zoom sessions so that we can also see what he is doing, but what he is actually experiencing in virtual reality, there is no way of understanding from our side. So we asked him to record that because the Oculus Quest has that option to capture the experience in that environment. So he captured all the videos and sent us later in the drive.
Okay, thank you. Okay. If anyone else has any questions, then if not, then thank you very much, Asha, for presenting and coming to our seminar today. We really appreciate it, and I'll reach out to you again in the future to ask some more things, probably. So, yes. So, everyone, we'll see you guys at Scrum later today, and unless anyone has any last minute questions, then then thank you guys for coming, and we'll see you guys later.
Thank you everyone for listening my presentation. If you have any queries, contact me in my email address.
Okay, looks like we're just waiting. Asha, I wanted to ask you about something that like has to do with your research. So how exactly, so for example, you did your bachelor's with computer science, is that right? So I have no idea how to do this, but so you guys had somebody record the wheelchair user doing it, and then you also asked him to take a recording and send it to you guys. So do you watch through all the videos and then do it, or do you like set up like markers and stuff on the software or in the software, and then whenever someone touches that marker or something, then it gets collected? Or did you just do that by like watching the video?
Oh, okay. Yeah, that's also a very good question. So we didn't actually apply that, but many of our research group members are doing that. Like in the software, we can ask the user to put the rating. How did he like the interface? Like from 1 to 5, he can rate in the software directly, like using the Oculus Quest headset.
Wow.
There is option to do that. Like we can create the simulation based on that. But when he is evaluating the scene, we can directly ask him the question, the thing that you asked. Many of the researchers are also using that, but in our case, it was not like required. I asked him to test the simulations, and then after testing the simulations, we asked the questions. Like one testing, and then